If you've ever seen a Victorian deep-sea diving suit, the kind with the enormous brass helmet, the thick canvas body, and the boots that look like they were stolen from a statue, it immediately raises a question. How did that work? Not how did it look, or how did they make it, but how did a human being actually survive inside something like that, underwater, for hours at a time? Because it doesn't look like sporting equipment. It looks like industrial machinery you accidentally put a person inside. And yet for much of the 19th century, this was the most advanced underwater life support system in the world. It allowed people to walk on the seabed, repair ships, recover cargo, and build underwater structures, all decades before modern scuba gear existed. It was revolutionary. It was also built around a single, unspoken operating principle. Just trust. Trust the suit. Trust the hose. Trust the pump. And, crucially, trust the man on the surface turning a hand crank, usually with a 1900s work ethic and a cigarette hanging out of his mouth like it was part of the uniform. To understand how these suits worked, you have to understand what problems they were trying to solve, and how Victorian engineers approached those problems using the materials and mechanics available at the time. Why the suit was needed at all before diving suits existed, underwater work was extremely limited. If something fell into the sea, you had two options. You could free dive, holding your breath. That worked in shallow water for very short periods and for simple tasks. Anything deeper or more complicated was out of reach. Or you could use a diving bell, an inverted chamber lowered into the water with trapped air inside. Diving bells allowed people to stay underwater longer, but they were stationary. You could work directly beneath the bell, but you couldn't walk around. That meant the seabed was effectively inaccessible, and this became a serious problem as ports grew larger, ships became more valuable, and underwater construction became unavoidable. Victorian engineers didn't see the ocean as a place humans didn't belong. They saw it as a place humans simply hadn't engineered yet. So they didn't adapt the sea to people. They adapted people to the sea. The diving suit was a system, not a costume. Despite how it looks, the Victorian diving suit wasn't a single object. It was a system made of several interdependent parts, each solving a specific problem. The helmet, brass, weight, and visibility. The most recognizable part of the suit is the helmet. It was usually made from brass or copper alloys, chosen for several reasons. Brass resists corrosion better than iron. It's strong but workable. It doesn't fracture easily under pressure. It could be cast, hammered, and repaired using existing industrial methods. The helmet typically weighed around 25 to 30 kilograms. It had multiple glass viewing ports, usually 3, one in front, one on each side. The glass itself was thick and slightly curved. This wasn't about comfort or clarity. It was about not collapsing under pressure. The helmet screwed or bolted onto a metal collar attached to the suit. Once it was locked in place, the diver could not remove it without help. There was no quick-release mechanism. If something went wrong, the plan was not take the helmet off. The plan was signal the surface and wait. The suit, canvas, rubber, and sealing. The body of the suit was usually made from heavy canvas. Canvas was chosen because it was strong, it could be woven densely, it resisted tearing. It was already widely used in sails and industrial work to make it waterproof and airtight. The canvas was often rubberized or treated with waterproofing compounds. This created a suit that was flexible but sealed, not rigid like modern diving suits, but not forgiving either. Any major tear, seam failure, or poor seal could allow water in, and water inside an air-filled suit is not a small problem. The suit had to remain sealed under pressure while also allowing the diver to move enough to work. It was a balance between mobility and survival. The boots, why lead was essential. The boots were massive. Each boot often had a thick lead sole, weighing around 15 to 16 kilograms. This wasn't excess, it was necessary. When you pump air into a sealed suit, buoyancy becomes a serious issue. Without weight, the diver would float upward uncontrollably. The boots ensured stability traction on the seabed-controlled movement. This is why Victorian divers didn't swim. They walked, slowly, carefully, and very deliberately. Combined with additional chest weights, a fully dressed diver could weigh well over 90 kilograms on land, which explains why nobody ever hurried into the water. The defining feature of Victorian diving was that the diver did not carry their own air. Instead, air was supplied continuously from the surface. This was done using a hand-operated air pump. The pump, gears, pistons, and human power. The air pump was a mechanical device, usually mounted on the dock or deck of a ship. It typically consisted of a hand crank, gears to regulate motion, one or more pistons intake, and outlet valves, leather seals, metal cylinders. As the handle was turned, the gears converted rotational motion into the linear movement of pistons. Each piston stroke drew fresh air into the cylinder, then pushed it into the hose leading to the diver valves, ensured air only moved in one direction. Leather seals were used because they could create an airtight seal while still flexing under motion. These seals required constant maintenance. They dried out, cracked, and wore down. This was not a precision medical device. It was industrial machinery, and it relied entirely on continuous human effort. If the handle stopped turning, air stopped flowing. There was no automatic system, no stored reserve, no redundancy. The diver's breathing rhythm was tied directly to the rhythm of the pump, which meant the surface crew had to maintain a steady pace, consistent pressure for the entire duration of the dive, sometimes for hours. The hose, a single point of failure. Air travelled from the pump to the diver through a thick rubber hose. The hose had to be flexible, strong, resistant to collapse under pressure, long enough to reach the seabed. It was reinforced and carefully inspected because a kink, tear, or disconnection could be fatal. The hose was also the diver's physical link to the surface. It carried air and risk. Air entered the helmet from the hose and filled the space around the diver's head. The diver breathed normally inside the helmet. Exhaled air mixed with incoming air, and excess pressure escaped through a one-way exhaust valve. This valve allowed air out but prevented water from entering. The steady stream of bubbles you see in old footage wasn't accidental. It was the system working as intended. The diver could sometimes adjust airflow slightly using valves, but they weren't fine-tuning oxygen levels. They were managing comfort and pressure in real time. Pressure where things became dangerous. Water pressure increases rapidly with depth. For the diver to breathe normally, the air pressure inside the helmet had to match the surrounding water pressure. This meant the pump operator had to adjust effort based on depth. Too little pressure, breathing becomes difficult. The helmet feels compressed. Panic becomes likely too much pressure. The suit inflates, buoyancy becomes unstable. Air can be forced into the body in dangerous ways. There was no gauge inside the helmet showing pressure. The diver felt changes rather than measured them. Victorian diving operated on experience, not instrumentation, and the ocean is very unforgiving of small errors. Decompression, the risk. They didn't fully understand. Modern divers use decompression tables to avoid decompression sickness, commonly known as the bends. Victorian divers didn't have this knowledge at first. They knew that ascending too quickly was dangerous, but they didn't fully understand why. As a result, divers sometimes surfaced too fast and suffered joint pain, paralysis, dizziness, confusion, collapse. At the time, this was often blamed on fatigue, weakness, or poor constitution, which is history's way of saying, we haven't figured this out yet. Inside the helmet, the world was small, sound was muffled, breathing was loud, vision was limited to thick glass windows, every breath echoed. Movement was slow and heavy, each step kicked up sediment, visibility could vanish instantly. There were no radios, communication was done using rope signals. A series of tugs meant different things. I'm okay. Give me more slack. Pull me up. Something is wrong. These systems varied by crew, but all relied on correct interpretation. If something went wrong, the diver tugged a rope and hoped someone understood. It was simple, and it was terrifyingly indirect. Why it mattered. Despite all of this, Victorian diving suits changed everything. They enabled underwater construction, harbour maintenance ship, salvage recovery of valuable cargo, early underwater engineering. They turned the seabed into a place humans could work, not comfortably, not safely by modern standards, but effectively. Why we stopped using them, modern diving replaced this system with self-contained air pressure regulation, redundancy, better communication, far higher safety margins. The Victorian suit wasn't abandoned because it never worked. It was abandoned because it worked at too high a cost. It had too many single points of failure. Most notably, the hose, the pump, and the man turning the handle deciding he'd earned a break. Conclusion: the Victorian deep-sea diving suit looks archaic now, but it was once the most advanced life support technology humans had ever built. It allowed people to walk where no one had walked before. It was heavy, uncomfortable, dangerous, and brilliant. And it worked because people trusted it. They trusted the materials, they trusted the mechanics, they trusted each other. Sometimes that trust was rewarded, sometimes it wasn't. And that's why it sits in museums now, not as a costume, but as a reminder of how far people were willing to go to push into places they didn't yet belong. Held together by brass, canvas, rubber, and trust. Mostly trust.